Today's lecture 23 of Basic Electronics is Full Adder. Welcome to our channel ClassFly Community. I hope all of you are having a great day. So let's begin with today's topic. Today we will be dealing with the topic full adder. Okay, we have done the half adder, right? Why we are basically doing full adder? See, we know that half adder, what does it do? It adds single bits, right? And whatever the carries come in, if it's 1 1 0, we are getting one carry, right? So we can't take this carry because we can only add one bit, that is 2 bits number. So we need this full adder due to this. See, full adder is an arithmetic logic circuit. Why it is an arithmetic logic circuit? Because we will do operations or additions to get our respective values. So half adder cannot add more than 2 digits, right? So it cannot add more than 2 digits. That is, if I want to add 0 1 1 plus 1 1 1, then it will not do, right? So when 3 bits needed to be added, whenever we need to add more than 2 bits, that is the 3 bits, we used a full adder circuit. Okay, see, this is a block diagram of full adder. So these are the inputs, that is the A and B, as well as this one is the input. This input we denote as CI because it will be the input carry, right? The third bit, and this will give us the carry, and this is the sum. So now we will first of all do our truth table. Okay, so as we are taking here 3 variables, so our first column will have 4 zeros first and then 4 ones. Why we are doing this? Because we know 2 to the power 3 is 8, and whenever we divide it with 2 we get 4, right? So we get 4. So in the first column we will get 4 zeros and 4 ones. Respectively, in the second column we do divide with 2, which will we get as 2 zeros and 2 ones, and again then 2 zeros and 2 ones. And when we again divide it with 2, we get 1. So in the respective third column we will do 1 0 1 1 until we reach the 7th row, or the 8th row, right? Our first one is the 0 and we are going till 7. Okay, so it can be the 8th row also if I start with 1. So now see, we know the binary addition. Now we have to know the binary addition for this full adder truth table. See, the binary addition is 1 plus 1 is 0 and we get 1 as carry. Similarly, 0 plus 1 is 1 and we get 0 as a carry. 1 plus 0 as 1, we get 0 as a carry, and for 0 plus 0 we get 0 and 0 as a carry, right? Simple. So this is basically our binary addition. Now we have to do 3 digits though. So how we will do? See, first we will take these 2 columns. So I am doing for the first row first. So 0 plus 0 is 0. So this 2 we get what the result as 0, and again 0 plus 0 is 0. So my sum is 0 as well as my carry. Similarly, we will do for the respective rows. 0 plus 0 is 0. Now 0 plus 1 is 1. No carry, so we are writing 0. Similarly for this, 0 plus 1 is 1. Now 1 plus 0 is 1. So 0, no carry. Now see, this is the interesting one. 0 plus 1 is 1 and 1 plus 1 is 1 0. So we write 0 for the sum and 1 is our carry. Because 1 plus 1 is 10 and this 1 is our carry, right? Now see, 1 plus 0 is 1. Again 1 plus 0 is 1, so no carry. Respectively, we will do for the rest rows. I am doing for the last one so you don't get confused. 1 plus 1 is 0, right? but we are still having a carry, right? So that carry we will sit first here. And now 0 plus 1 is 1. So we are getting sum is also 1 and carry is also 1. This is the twist in the last row. So be very careful. Now whenever we can do our equations by seeing the truth table also, but prefer for the full adder do K map. So as here there are 3 variables, we will use this K map. Okay, that is the 8 boxes one. So first let us do for the sum one. So see, for the sum K map, let's solve this. See, first make 8 boxes. These are the 8 boxes you made. And now start numbering. So you will number from 0. So 0, 1. After 0, 1, jump to the last. 2. Then again come back to this. So this 3. Then again 4, 5. Again jump and then come back. So what we are doing? 0, 1, jump. Jump back 3. 4, 5, jump back 7. We are doing this one. Now we have 3 variables. So we will write in here we will only write 1 variable, that is A, and here we will write 2 variables, that is B and C. Now see, here we will write first 0 and then 1. Okay, and here we will start with 0, 0. We will do 0, 1 and then again we will jump and we will come here with 1, 0 and here we will write 1, 1. Okay, perfect. Now see, for this sum one, what we had, we have to see where there was 1. So let's go to the truth table again. So this is the truth table. So here it is at 1, 2, 4 and 7. So 1, 2, 4 and 7 we will do in the K map. So at 1 I will write 1, at 2 I will write 1, at 4 I will write 4 and at 7 I will write 7. See, here we can't group it, right? So this is the check box one. So whenever there is the check box, so the equation will always be A XOR B XOR Ci. You remember this, whenever everything is can't be grouped, at that time it is the checkbox one. So the equation for the sum will be A XOR B XOR Ci. Similarly, now we will do this for the carry. This one is for the sum. Now we will go ahead and do for the carry. Okay, see, this is the carry one. I have already done for the sum, so I am just making you understand what you will do. You will first do the 8 boxes, then what you will do, 0, 1, jump back 3, 4, 5, jump back 7. Okay, now you will see where 1 is coming. 1 is coming at 3, so I will write 3 at the 3 box 1. It's coming at 5, 6 and 7. So 5, 6 and 7 I am writing. Now here, as I can group it, so I will group it like this, like this, like this and like this. Okay, so when I solve this, I get, and how I will get, see, if I take this one, see here as 0 and 1 is changing, so I can't write for A, but I can write for BCI as there is no change in the bits. So it will be BCI because for 1 it is non-complemented, right? Now see for this one, as B is changing from 0 to 1, so I can't write B, but I can write A here. So my A will be A and Ci is not changing from 1 to, it's same, that is it's 1 and 1, so I will write Ci. Now for this one, as my Ci is changing from 1 to 0, I will not write Ci, I will only write B. So I wrote B, and as A is also not changing, I will write A. This is one of the K-map. K-map can have various equations. Solving thing can be different. So we will prefer here the full adder equation, not this one, another one we will do, which will be, I'm showing you. So for the carry one, what we will do, we will try to get the equation AB plus C in A XOR B. See, we got AB plus BCI plus ACI. If I solve this equation and bring this one, this will take a lot of time and it will be wastage of time for you all in your examination. So always remember, whenever you are doing the full adder for carry, always try to do the K-map for this equation. So let's do the K-map and remember this equation. For checkbox, this is the equation, and for carry, for full adder, you will do this equation. Okay, so let's do ABCI 0 1 0 1 2 3 4 5 6 7. Okay, so what was 1 1 1? Okay, one zero one one. Okay, it happened, right? So what I will do now, I will have to bring this one, right? AB plus C in A XOR B. So I will bring this equation with the K-map here. So if I do, so see, we will group here like this. One group I will do for this one group for this, and one for this, right? Now see, if I do for this one, it will be A, as here is no change in the bits, so it will be A bar B Ci, because for 1 it is non-complemented, right? Now I will do for this one, as A is not changing, so A B bar, because 0 is complemented, and Ci. And now this one I will do, which will be 1 and 1, that is the B1 is not changing, so I will write B, and for Ci I will not do, as the bits are changing, right? And here 1 is not changing, so write AB. Now see what I got. AB I got similar to this. If I take Ci, that is a C in, like this, C in or Ci, whatever you will prefer, and I do A bar B plus AB bar, which is A XOR B, right? So I got the equation, that is AB plus Ci is A XOR B, right? So I got this equation. So always prefer this K-map to bring this equation. Okay, now we will see the logic diagram for this two equation. So let's do. So these are the two equation. First, do like this, make 3 straight lines. Okay, this one will be A, this is B, and this is Ci. So what is same? First we will make for the sum A XOR B. So what I do, I started this A and I started this B and I made a XOR here. So I get A XOR B, right? And now I will do for Ci, and again for, if I denote this as D, so this will be D, right? And now D XOR Ci, then I will do this. So what I get, D XOR Ci, which is my sum. I got the sum. Now I will do for the carry. So first do the A XOR B. So I take here from here A XOR B. With this I will do CI. As it is into, that means it is AND. So I will do an AND operation here. This is a CI A XOR D. And now AB. We will do A, will take A, we will take B, and we will do the same AND operation. We got AB from here, and with this we will do, as it is plus, it is OR. So we will do a OR gate and we get a carry. So it's simple. So whenever you do part wise. First try to do the sum part and then try to do the carry part. So like this we will make a truth table, we'll make the K maps for the sum and the carry, and this will be our equations and this will be a diagram. I hope you all understand what is full adder and how the full adder is done. So till then, be happy and have a great day. Now it's the code time. Find people who will make you better. I hope all of you understood today's lecture, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.